them prevents the occurrence of other. It means that when the two events can't occur simultaneously, okay, only at a time one event will occur over the preference of other. For example, if I toss a coin, okay, so either head or tail will come, right? So in this case, head and tail both are mutually exclusive. So how we can denote the mutually exclusive events? That means their simultaneous occurrence can't occur. So in this case, if we have two events A and B, if we have two events A and B, then their intersection will be an empty set. So the student जिनका मैथमेटिकल बैकग्राउंड नहीं है या जिन्होंने सेट्स नहीं पढ़ा है, तो उनके लिए मैं बता देती हूँ कि ये जो नोटेशन है, ये दिस इज कॉल्ड इंटरसेक्शन. इट मीन्स कि अगर आपके पास दो सेट्स हैं ए और बी, तो उसमें आप ए इंटरसेक्शन बी में उसके कॉमन एलिमेंट्स को लिस्ट करते हो. For example, if I throw a dice, right? So what would be the sample space? Sample space क्या होगा इसमें? 1, 2, 3, 4, 5, 6. ये outcomes आएंगे sample space में. Now, if I have the event even, that is the digit on the die is even. So event even के outcomes क्या होंगे? 2, 4, 6. Next event I can take E2. E2 I denote by the digit on the die is odd. So E2 can take the outcomes 1, 3, 5. And another event E3, that the digit on the die is prime. Then E3 will have the outcomes 2, 3, 5. So if I take the intersection of E1 and E2, E1 and into E2, so मैंने आपको जैसे बोला कि इंटरसेक्शन में हम क्या लेते हैं, कॉमन एलिमेंट लिस्ट करते हैं. तो इन दोनों में कुछ भी कॉमन नहीं है, तो दैट मीन्स इट इज ए एम्प्टी सेट. सो इफ E1 intersection E2 is empty, then those events are called mutually exclusive. So in this case, event of getting even number and odd number is empty set. That means when I throw a dice, either even number will appear or odd number will appear. So either of one will appear. Clear? But if I take the another set event like E1 and E3, so E1 and E3 are not mutually exclusive. क्यों नहीं है mutually exclusive? Because if I take the intersection of E1 and E3, the common point is 2. So intersection is not empty because 2 is both prime and even. So E1 and E3 are not mutually exclusive. Similarly, we can say E2 and E3 are also not mutually exclusive because the intersection is 3, 5, which is not empty. So E2 and E3 are again not mutually exclusive. Got it? So next definition is collectively exhaustive events. So what are collectively exhaustive events? So two or more events are said to be collectively exhaustive if all the elementary events under the experiment are covered by the event considered together. It means the two or more events are said to be collectively exhaustive if they complete the sample space. मतलब कि जितने भी आपके सारे सैंपल स्पेस के एलिमेंट्स हैं वो सारे इवेंट्स मिलाकर उस सैंपल स्पेस को कंप्लीट कर दें. For example, again I take the same example of throwing a dice. So in this case, I have E1 as the outcome of even number 246, E2 as outcome of odd number, that is 135. So if I take the union, or I take a combine there, so use here E1 union E2 will be 246135, right? So what are the elements in the sample space? Again 1 2 3 4 5 6. So these E1 and E2 are called the collectively exhaustive events because they complete the sample space. Even see E1 and E2 here also mutually exclusive. So E1 and E2 in this case are both mutually exclusive and collectively exhaustive events. So again, I say this sign U suggests the union. What means U? U means union of two sets. It means we have to combine all the elements of both sets in a single set. But here remember, repetition is not allowed and ordering here is not as such important. You can list the elements in any order. Now, next definition is complementary events. So what are complementary events? So two mutually exclusive events. See, two mutually exclusive events are said to be complementary if they are exhaustive also. That means the two mutually exclusive and exhaustive events are called complementary events. So I can say the complementary event means the happening of one is equal to not happening of other. Okay. For example, toss of coin. The sample space is head and tail. So probability of occurrence of head is equal to 1 minus probability of occurrence of tail. Okay. So probability of head equal to 1 minus pt. That is head की probability क्या होगी इसमें 1/2 और tail की भी 1/2. So 1/2 is equal to 1 minus 1/2. So these two events are called complementary events. So two mutually exclusive and collectively exhaustive events are called complementary also. Now next definition is independent events. Independent events. Two events are said to be independent if probability of occurrence of one is independent of previous occurrence of other. That means if an event occur, then it is independent of the previous occurrence of the other event. For example, in successive tosses of coin, if I toss a coin and first time I get head and I toss it again, then second time tail eye, head eye, it is independent of the previous occurrence of head. So these events are called independent. There is another thing also, the drawing with replacement. What is drawing with replacement? Drawing with replacement means, so when we are drawing something, for example, if I have the pack of cards. So in pack of cards, we have how many cards? 52 cards are there. Okay. So there is 52 cards. So if I pick a card and put it aside, if I pick a card and it happens to be queen, then I replace that card again in the pack. Okay. So now again the total cards are also are the same 52. So again, if I pick a card, then the probability of queen or king would be same. It is independent of the previous one, right? So this the drawing with replacement is another example of independent events. ड्राइंग विद रिप्लेसमेंट का सिंपल मीनिंग है कि आपने निकाला उसमें से और फिर उसमें आपने दोबारा उसको डाल दिया, मतलब आपने सैंपल स्पेस फिर से कंप्लीट कर दी. फॉर एग्जांपल जैसे अगर आपके पास बैग है, बैग में आपके पास रेड बॉल्स हैं और ग्रीन बॉल्स हैं. सो आई से इफ यू हैव 2 रेड एंड 3 green. If you had 2 red and 3 green. So now probability of red will be 2 by 5. So if you put that ball again after picking in the box and again pick a ball, then probability of red will be same. There would be no change. Okay? It is independent of the previous drawing. So these are called independent events. Now next definition is dependent events. So what is dependent events? Dependent events are those in which the occurrence of one is useful in assessing the occurrence of other. In other words, I can say the occurrence of one is dependent upon the previous occurrence of other. So here comes the case of drawing without replacement. What did it say? Drawing without रिप्लेसमेंट. विदाउट रिप्लेसमेंट का मतलब क्या है कि मैंने अगर पैक ऑफ कार्ड्स का एग्जांपल है तो पैक ऑफ कार्ड में से एक कार्ड निकाला और उसको साइड कर दिया, फिर सेकंड कार्ड निकाला, तो यहाँ पे मैंने इसको रिप्लेस नहीं किया फिर से. फॉर एग्जांपल अगर if I draw a card from the pack of card that happens to be queen, so that means first card is queen, and if I put that card aside and pick another card, if that second card be again queen, then its probability depend upon the previous occurrence of other. कैसे? If I pick the first card that is queen, then probability of first queen I denote by P, probability Q1, it will be 4 by 52 because there is 4 queens and total cards are 52. So this is 1 by 13. And if I put this card aside and again pick the card, then probability of second queen, that is Q2, will be 3 by 51 because there were 4 queens initially and 1 I put aside. Now remaining will be 3. And again from the 52 cards, 1 card I put aside, so total will be 51. So now the probability is 1 by 17. तो आप इसको ऐसे भी समझ सकते हो कि विद रिप्लेसमेंट केस में आपकी प्रोबेबिलिटी हर एक ट्रायल में सेम रहती है, लेकिन विदाउट रिप्लेसमेंट में बीइंग स्टैटिस्टिकली डिपेंडेंट इवेंट्स आपकी प्रोबेबिलिटी सेम नहीं होगी each trial में. Now next is some more terms associated with probability. Operation with events. So how we operate with events when we solve the problems. Now first is A union B. What it means? If I have A union B, the A union B denotes the occurrence of either A or B or both A and B. It can also be used if I have to find the probability of occurrence of at least one. Probability of at least one of A or B. If there is a question it is asked find the probability of occurrence of at least one. So then you can use A union B when you have two events. Now next is A intersection B. It means here E. Intersection means and. So it denotes the occurrence of both A and B simultaneously. A and B. Right? So if you have to find the probability of occurrence of A and B, then you can use intersection. Now next is A minus B. A minus B means difference of two sets. It means the occurrence of A with the non-occurrence of B. It can also be denoted by A intersection B complement, or we can say when you have to find the probability of occurrence of only A. Only A. Now next is complement. Complement means A complement. Complement means not A. Simple meaning of complement is not A. Or A bar. It denotes the non-occurrence of A. So generally probability of not occurrence of A is equal to 1 minus probability of A. So these are four basic laws which we used in solving problems. Now next is fundamental rules of probability, that is also called axiomatic rules of probability. Axiomatic rule. So it says let S be the sample space and A1, A2, so on, AN are events, exhaustive events associated with it, then probability of occurrence of any event lies between 0 and 1. So the minimum value is 0 and maximum is 1. Now second rule is if A is an impossible event, then probability of A is 0, and if A is a sure event, then probability of A is 1. And third rule is probability of sample space. That means sample space में जितने भी आपके outcomes हैं उनका आप sum करोगे, उनकी probabilities का sum करोगे तो आपको आंसर 1 मिलेगा. Now fourth rule is probability of not happening of an event is equal to 1 minus probability of happening of event. Okay, the same as which I have written here, probability of A complement is equal to 1 minus probability of A. So I hope you understand this, and now we'll do the laws and some more definitions of probability in the next video. Thank you.